Welcome. We are here to talk about curves. It's an honor and pleasure for us. During our career, we had the chance to work on grid projects that let us deal with complex shapes, curving surfaces, and with a mix of different materials. Thanks to these projects, we have been able to join and match our two souls, thinking and doing. Joining them, we have been able to create solutions, spaces, details, emotions. Today, we would like to show you 4 projects, 4 solutions that in different ways led to the division of complex surfaces into constructible and simple sub-elements. The Nuvola by Fuksas, the desk at Maxi Museum in Rome by Zaha Hadid, Musée du Cré Branly bench by John Well, the National Museum of Qatar gift shop by Koichi Takada Architects. Ready? Let's go!
We will start with a project where curves are not really curves. It is the Nuvola Auditorium. It has been a very important project for us, a project where we turned a complex surface into simple geometry.
For those who don't know, Nuvola is a convention center designed by Fuksas. It looks like a big white floating cloud enclosed in a glass case. Nuvola is the Italian for cloud. Inside the big white cloud, we find the auditorium, a novel structure that we were asked to clad both inside and outside. The internal and external cladding are different. The inside is in cherry wood, while the outside is in black wood. The two claddings are different, not only for the color, but also for the geometry and size. They have something in common, though. Their surface is curving, but supposed to be clad with straight panels. But let's start from the beginning. Everything started with this picture. This is Claudio Devoto on site. He is staring at nothingness. There was nothing but concrete and the base building structure. It was hard even to imagine how to run the 3D surveys in those conditions. But we did it. First thing, we cited the designers and the engineers to match the main design with the data related to the nodes and features of the base building.
So, according to the 3D survey we had run and according to the surface that we designed again, we identified clashes, compliances, and changes that were necessary to design the substructures first and the panels afterwards. The engineering work was fundamental, essential. The matching the main design to the 3D survey data was the basic for the geometry optimization we needed to obtain a parametric and construction design of the metal substructure.
The engineering of the substructure was entirely developed by Devoto. We conceived the substructure for the internal cladding and a substructure for the external cladding.
The external cladding is not so large as the internal one, but proved to be more complex because of the pre-existing elements that we had to deal with, such as pillars, doors, fire extinguishers, balustrades.
In order to fix the substructure of the internal cladding to the base building, we needed to mark its coordinates and position on the concrete surface. We're talking about a huge space, so we decided to ask the intervention of an extremely professional and ultimate tool, the paintball rifle. Yes, we called the professional paintball sniper and asked him to mark the walls and ceiling with red paint. It was fun and quick too. Fixing the metal substructure was now a piece of cake.
Allora, questo alle mie spalle è il prototipo della nuvola di Fuksas in scala 1:1 che è ancora qui in azienda. Siamo nella parte posteriore del mock-up in cui potete vedere tutta la struttura metallica che serve per sorreggere l'intera pannellatura in legno.
While installing the substructure, we started working on the wood surface. Since it was an auditorium, we needed to use panels with specific acoustic and isolation performances, straight panels, that we purchased from specific manufacturers. Well, how can we clad a curving substructure with straight panels? How can we know the quantity of panels we need? In a nutshell, where do we start from?
Once the 3D survey was done and the metal substructure was designed, The first thing to do was to obtain a parametric design of the surface from the original point we had identified at the very beginning. We engineered the surface and treated it like a big jigsaw puzzle. We identified all the pieces and marked them with a specific code that identified their position in the puzzle. This process is called tessellation.
Everything was ready now. We had a number of panels, their dimensions, shape, and we had a solid substructure waiting for them to be fixed. There was just a little tiny problem. How do we curve straight panels? We came up with a simple idea. We carved the back of the panel so that they could be bent to reach the desired level of curve. There was no pre-assembly for this project. The panels were taken straight to site, and thanks to this mechanical technology given by the back carving, they easily reached the desired level of curve when installed on the substructure.
Potete vedere le varie lavorazioni che sono state fatte, le incisioni sui singoli pannelli di legno per poter rendere questa forma curva.
Here you can have a look at some project numbers. We use 4,687 panels on the inside and 2,349 panels on the outside. You can also see the different types of pieces of the puzzle according to their shape and level of curve.
For the tessellation and to obtain the exact number of panels, we conceived a specific algorithm, a high level of engineering that Devoto put at service for this great project.
Building the Nuvola Auditorium was hard and took a lot of work and time. We started in 2013 and finished in 2015. It's been a controversial project for many reasons, but we are extremely proud of what we did. We went back there in 2021 to deliver the interiors that Fuchsas designed for two new areas of the building, the bookshop and workshop. Again, we dealt with complex curving elements, even though we used a different kind of technique. The same technique we will talk about in the next project.
Our second project is the first experience we had with Zaha Hadid architects. We had the chance to work at the Maxi Museum of Modern Art of Rome, where we delivered the desks that are scattered around the museum. Today's focus is on the archive room desk, an out-of-scale desk that is 14 meters long, has variable height, an organic shape, and a consistent and almost plastic look. We received a sketch, but also a detailed 3D model where shape, curves, and lines were already clear, as well as the level of complexity of the item. The main question was about the finish. Zaha Hadid's intent was that of obtaining a monolith, a one-piece desk with a consistent and smooth surface and no visible joints.
We had to exclude acrylic resin, Corian and similar because of the intensity of the curves and shape of the desk. It would have been hard and also quite expensive to turn the straight panels like this, it is a sample of Corian acrylic sheet, into curving sub-elements. Imagine how many molds and vacuum forming operations we would have needed. That's why we opted for the gel coat. As you know, this technology is mainly used in nautical construction and it perfectly matched our requirements. Our journey started with a presentation of a scale mock-up, a little maquette for Zaha Hadid, to be inspected and to be approved because before starting production we have to be sure about our interpretation of both the shape and the finish. So we realized on internal structures in wood and an external finish in gel coat.
Ricordo ancora il giorno dell'ispezione. Eravamo emozionati e nervosi allo stesso tempo. Emozionati per l'incontro con Zadid e nervosi perché temevamo il suo giudizio. Eravamo tante persone sedute in riunione a questo tavolo per ispezionare il modello e aspettavamo il commento di Zadid. Il suo commento, vedendo il prototipo e indicando il lato lungo del bancone, fu un po' meno pancia. A quel punto poi lei prese e se ne andò. Noi rimanemmo tutti un po' interdetti e ci domandammo: è andata bene, è andata male, le sarà piaciuto? Quindi alla fine siamo rimasti per breve tempo con questo dubbio, però poi alla fine l'ispezione è andata bene e è stato un successo.
After changing the design, then, we started the engineering by cutting the desk into 3 portions. That was necessary for logistics and transportation reasons. The core of the desk is timber. We conceived an empty structure made of wood strips, each of them engineered and numbered according to their position. Once the 3 portions of wood were completed with the requested equipment, let's not forget that it is a desk we're talking about, so it had drawers, doors and shelves inside. The surface was covered with a combination of fiberglass and resin to make it thicker and ready to be finished with gel coat.
Il gel coat è una resina che viene data a spruzzo, a rollo, a pennello e rende la superficie compatta e resistente. È un prodotto che una volta dato è molto lucido e abbiamo lavorato carteggiandola, rendendola opaca in funzione delle richieste del cliente, in questo caso di Zadid.
Come abbiamo detto, anche la logistica era complessa, quindi abbiamo trasportato le 3 sezioni differenti del bancone in cantiere, le abbiamo sollevate con una gru e le abbiamo fatte accedere attraverso una rampa di servizio. Detto così sembra facile, in realtà il cantiere era in divenire, pieno di gente e questo rendeva tutto più complesso.
Once there, we assembled the 3 pieces and worked the joints to make them invisible. And here it is. Let's go to Paris now to show you the first project we have run with Atelier Jean Nouvel. We're talking about the Musée du Quai Branly. We were involved in the renovation of the large entrance lobby. Specifically, Jean Nouvel designed a long curving bench that works both as a partition element that conceals the escalators and as a bench, of course.
It has a mixed structure, solid wood and solid surface.
If you have a look at the drawings, but also at the completed work, you will say, well, no big deal. But this was not what Jean Nouvel had in mind. The solid wood portion of the bench is designed to have a visible vertical pattern. The bench was designed to be made of hundreds of curving strips of wood that show no horizontal joints. Well, that can be easily handled with veneer, can't it? Sure, but Jean Nouvel wanted solid wood at all costs. So we engineered the bench and sliced the seat into more than 100 strips, as you can see on the drawings. As you can see, these strips have different shapes and curving levels, and all of them are 14 millimeters thick. But how to bend 100 different solid wood strips?
Well, the only possible solution that could meet time and budget was the steam shaping technique. With steam and proper machinery, it is possible to bend the solid wood into the desired shape.
For every strip, we engineered and produced an iron mold. The mechanical process triggered by the action of the steam bent the wood on the mold, reaching the desired shape.
This reminds us that wood is a living material, a material that is sensitive to temperature, moisture, and weather conditions. But we will better talk about this in the next project.
Meanwhile, we manufactured the main structure of the bench, which is made of wood and clad with solid surface. The solid surface with thermoform to reach the design curves. We engineered and manufactured the molds and thermoformed the solid surface sheets that we laid on the timber core the bench is made of. The core is similar to that of the Maxi Museum desk. We use the same design and manufacturing process. Then the wood strips were inserted onto the structure. We decided to pre-assemble the bench that we had engineered so that it could be divided into portions that we could easily transport and handle on site. The installation took place at night because the museum was already open to visitors during the day. Here is a short video. And this is the final result.
How to make a wooden canyon? Come with us.
These are the 2 gift shops that can be found inside the National Museum of Qatar. The wooden canyon is the biggest of the two. The other is smaller and dedicated to children. They were both designed by Koichi Takada architects. For both, the studio conceived a three-dimensional and curving surface of wood inspired by the Cave of Light in the Qatari desert. In fact, when you enter the main gift shop, you feel like walking in a canyon. It feels out of place and out of time. It's magical. As you can see from the renders, we were asked to produce a cladding made of thousands of horizontal curving wood strips and a substructure to hold them. That was our scope of work.
The first thing we discussed with the designers was the material. KTA wanted oak. We could not use veneer because can you imagine how much time is needed to veneer 60,000 wood strips? We had to find a solution that could compress time and budget. So we switched to solid wood, but solid wood is a living material that tends to move, to crack, to adjust to the environmental conditions. And we already know that the wood strips had to travel by sea in refrigerated containers and be moved into an extremely hot place. For this reason, we suggest we use finger joint boards of solid wood. As you know, these boards are made of solid wood strips glued by wedge-shaped teeth. This creates an extremely stable and almost distortions-free connection, the perfect compromise between what the designer wants and the construction needs.
Yet, we needed to check the reaction of this material to weather changes, so we decided to run a test and check the thickness changes of a panel that we left outdoor. As you can see, we registered slight changes that in such a complex and big project can actually mean a lot. Our engineering team had to bear this in mind.
A variation of a tenth part of millimeter on the wood strip can be bring to a difference of 30 millimeters on the whole height of the cladding. A variation of 1 millimeter on wood strip can bring to a difference of 300 millimeters on the whole height of the cladding. That's a big deal.
We couldn't control the reactions of wood, we couldn't prevent it from shrinking or swelling, but we could find a way to manage it on site. How? Thanks to the substructure and its adjustable wings.
The whole project revolves around the substructures that holds the wood strips. So the first problem we had to deal with was the fact that it was not possible to fix the substructure to the base building. So there was no way we could touch Jean Nouvel's walls. This means that we had to run a complex and accurate structural calculation and conceive a self-bearing structure.
So we started with a 3D survey. We matched the 3D model we had to the 3D survey we ran and fixed the clashes and imperfections we found. Then we started to design the self-bearing structure, a system of bridges made of stainless steel, the result of complex load calculations made of pillars and adjustable wings.
Hi, my name is Claudio Devoto. First, I am a carpenter. After, I am a manager, a owner, a businessman. But my vocation, my mission is to be a carpenter. My English is terrible, and so I prefer to speak in Italiano, in Italian language. I am sorry, but it's better. And so we speak in Italian. Io devo approfondire il tema dei bridge, dei ponti, della struttura di metallo che sostiene le parti di legno che qui verranno avvitate a questa struttura di ferro. Questa struttura di ferro doveva essere leggera e doveva dividere il peso sulle varie pareti senza concentrarlo, e quindi abbiamo dovuto fare tanti pezzi di ponte, di profili che fanno il giro e scendono di qua, e scendono di là, e scendono di là, e si aiutano uno con l'altro. Dovevano essere strutture leggere e dovevano essere messe in certi posti specifici per non fare dei carichi di punta sul solaio. e quindi abbiamo dovuto scegliere questa posizione. Adesso se voi vedete tutti questi pezzetti qui, sono il trucco che abbiamo utilizzato per avvitare qua dietro i pezzi di legno. I pezzi di legno sono avvitati a queste lingue di metallo che hanno due fori per metterci la vite. Il problema è che a volte questa roba è dritta, ma a volte è in curva. Io collego in curva o delle curve questi pezzi. E questi pezzi quindi devono essere, il trucco era di farli registrabili. Registrarli significa poterli muovere. E quindi siamo partiti da questo studio di questo prototipo, con il quale abbiamo convinto i committenti a utilizzare questo sistema. Questo sistema altro non è che linguette che io posso piegare, forse si vede, in ogni direzione per poter avvitare qua dietro i pezzi di legno. Qua ci stanno i pezzi di legno e qua ci stanno le viti. E a seconda della curvatura del pezzo di legno, rispetto a questo asse, questo si curva, si piega e mi accoglie e mi sostiene i pezzi di legno. Questo trucco ci ha permesso di costruire 40.000 pezzi di legno avvitati a queste strutture che fanno ponte e che ha funzionato tutto e sono lì forti e robuste.
Then we started the engineering of the wood surface. We used a parametric approach to divide a complex surface into constructible and simple elements, the wood strips. We created our own rhinoceros software for the tessellation. Similarly to the Nuvola project, we had to divide the surface into sectors, the sectors into the wood strips, and then send them to the CNC machines for the cutting through our nesting software. At the same time, we engineered the drawers, adjustable shelves, and doors that the bottom part of the cladding is made of. Let's not forget that it is shop we're talking about after all.
Allora, questo è il nostro nesting di questi pezzi che serve per ottimizzare i pannelli e gli sfredi. Da qui sono usciti questi pezzi con un'incisione che serve per delineare la linea di appartenenza, il settore e la parete. Poi ci sono altre incisioni che servono per collegare il secondo pannello senza battere metro e velocizzare il montaggio.
We soon had thousands of pieces of wood, one different from the other. We sanded them and finished them with a natural, fire-resistant oil that KTA had selected, a product that didn't alter the nature and color of the solid wood, despite its powerful fire retardant action.
Allora, le operazioni di stoccaggio erano fondamentali, dovevamo rendere l'installazione il più agevole possibile. Così abbiamo personalizzato i carrelli e abbiamo diviso i listelli di legno già in base al settore e alle pareti. Volevamo che fossero al punto giusto al momento giusto.
As we said, the trolleys traveled by sea in refrigerated containers. Then they spent a couple of days under the scorching sun of Doha and brought to the museum, where AC was sometimes on and sometimes off. So, according to our provisions, the wood strips suffered heat and moisture changes. First they swelled, then they shrank, and then they swelled again.
The result? We were not able to install the last line of wood strips. There was no room for it. This did not cause any problem because the substructure, as we conceive it, had taken this possibility into consideration and helped manage the problem easily.
This is what we did, what we do, the way we can find solutions and make everything possible. We are ready for the next challenge. Thank you for your attention.